All right, so what we're going to do today is section 13.5. Before we do that, we're going to quickly review the pre-class items. And if you haven't done so already, you might want to try solving these two questions. So if you notice in number one, it says solve for triangle ABC. And if you recall, when we solve a triangle, what we're looking for are all of the missing pieces. And real quickly, in a triangle, remember, you need to have 3 angles and 3 sides. So if you don't have 3 angles and 3 sides, you need to solve for what's missing. And in number one, you can tell that you're given angle A, you're given angle C, and you're missing angle B. So immediately what we can do is solve for the missing angle. So let's go ahead and write that down. Okay, so I have angle A is equal to 33 degrees. B, I don't know yet. And I have C, which is equal to 90 degrees, and that was told to me. To find angle B, remember that a triangle, all 3 angles have to add up to 180. So we can take 180, and we can subtract the other 2 angles, so minus 33 minus 90, and that's going to give us our missing angle of 57 degrees. All right, we need a side A, we need a side B, and we need a side C. They give us side B, which is 17. And if you notice, the angle given and the side given. So we have the angle and the adjacent side, and we can solve for either A or we could solve for C. So let's solve for A, and A is the opposite side. So let's set up that trig equation. So we have the tangent of 33 degrees equals the opposite side, A, over the adjacent, 17. So A equals 17 times the tangent of 33 degrees. I just need to verify that my mode is in degrees real quick, and it is. Okay, so let's type that in. We have 17 times the tangent of 33 degrees, and I get 11.0 for A. All right. And then over here for side C, we can set up that trig equation. So how about cosine? Cosine of 33 degrees equals the adjacent side, 17, over the hypotenuse, C. And we get C equals 17 over the cosine of 33 degrees. So typing that in, we have 17 divided by the cosine of 33 degrees. And we get 20.3 for C. And there you go. You have all 6 pieces of information for this triangle. All right, same thing for number 2. So we have a right triangle. So let's draw a quick right triangle. Here is the right angle. That has to be C, and it doesn't matter where A or B is. All right, then we were told angle B is 41 degrees. Side C is 22. So we need to solve for side B and side A and angle A. So first step, we can find angle A by subtracting. So 180 minus, minus 90 minus 41, and we get 49. All right, so let's solve for, let's do, A first. So that's going to give us the cosine. So the cosine of 41 degrees is equal to the adjacent side over the hypotenuse. So A equals 22 times the cosine of 41 degrees. All right, and we get 16.6 for A. And then for side B, we have the opposite and the hypotenuse. So we have the sine of 41 degrees equals the opposite over the hypotenuse. So B equals 22 times the sine of 41 degrees. So B equals 14.4. And there you go. That's number 2. All right, so for section 13.5, we're going to apply the law of sines. Now, what we're learning in today's section is how to go beyond solving right triangles. So up until now, we've been solving right triangles. But guess what? We may have to solve triangles without a right angle. So in order to do that, we need some information. And we're going to be able to apply something called the law of sines. Now, real easily, we can solve any triangle with the law of sines if I know the following pieces of information: 2 angles in the third side, or 2 angles in the included side. Now, we can also use the law of sines in a third case when we have 2 sides and a third angle, but this one's a little tricky, and we're going to talk about that in just a second. Okay, so here is the law of sines defined. So in any triangle, the law of sines is defined as follows. Sine of A over A equals the sine of B over B equals the sine of C over C. Now, both of these statements are actually equivalent. So reciprocals of fractions are also equal, so you can write them in the way you want. And this is called an extended ratio. So in reality, you can just set up the first 2, or you can set up the second 2, or you can set up the first and the third. Okay, whatever you happen to need at the time to solve the triangle. So in example 1, we're told that triangle ABC, A is 94 degrees, C is 67 degrees, and B is 25. So let's go ahead and draw a obtuse triangle. Doesn't have to be perfect. With angle A equal to 94 degrees. And let's call that B, let's call that C. And C is 67 degrees. And then side B is 25. So if you notice, angle, side, angle. So this is the angle, side, angle case. Okay. So right off the bat, we can solve the missing angle by using 180 minus 94 minus 67. And we get 19 degrees. So angle B is equal to 19 degrees. Now, we needed to solve that first because in order to use the law of sines, you need an angle and an opposite side. So let's set that up. So we have the sine of 19 degrees, that's angle B, over side B, which is 25, equals. Now we have C and A, so we can do either one. Let's go ahead and do A. So we have the sine of 94 degrees over side A. To solve this ratio, you simply cross multiply. So we have A times the sine of 19 degrees equals 25 times the sine of 94 degrees. Divided by the sine of 19, you have A equals 25 times the sine of 94 degrees over the sine of 19 degrees. So A is equal to something. Let's go ahead and type that in. 25 times the sine of 94 degrees divided by the sine of 19 degrees. And we get 76.6. All right, now let's solve the other one. I'm going to use the first ratio again. So sine of 19 degrees over 25 equals, now let's go to C. Sine of 67 degrees over C. Cross multiply, C equals, let's back up just a second. So C times the sine of 19 degrees equals 25 times the sine of 67 degrees. So then C equals 25 times the sine of 67 degrees over the sine of 19 degrees. So C equals, all right, let's go ahead and type that in. 25 times the sine of 67 divided by the sine of 19. And we get 70.7. And we are done. All right, so now we have 2 guided practice problems. All right, so I would go ahead and draw this picture out. So we have an obtuse triangle. We're going to call that C, which is 100 degrees. Let's call that A. Let's call this B. And B was 34 degrees. And then side B is 8. So if you notice, this case is the AAS case, angle, angle, side. All right, so immediately let's find angle A. So angle A is equal to 180 minus 34 minus 100. And I get 46. All right. And now let's set up a ratio and let's solve side C and side A. So for my first case, I'm going to set up, let's do it up here. Let's see here. I have B. So sine of 34 degrees over B, which is 8, is equal to the sine of 100, that's C, over C. And I'm just going to skip a step here. So C equals 8 times the sine of 100 degrees over the sine of 34 degrees. So C equals 8 times the sine of 100 divided by the sine of 34. And I get 14.1. All right, now for the other one. So I have the sine of 34 degrees over 8 is equal to the sine of 46 degrees over A. And again, skipping a step, A is going to equal 8 times the sine of 46 degrees over the sine of 34 degrees. So A is going to equal, so we have 8 times the sine of 46 degrees divided by the sine of 34 degrees. And I get 10.3. All right, same thing for for number 2. So this looks like we're going to probably have several acute angles, A, B, and C. A is 51 degrees, B is 44 degrees, side C is 11. So this is the ASA case, angle, side, angle. All right, immediately let's find the third angle. So 180 minus 51 minus 44. So angle C, is 85 degrees. All right, and that tells me how I can set up my first ratio. So the sine of 85 degrees over side C, 11, is equal to, let's do A first, the sine of 51 degrees over A. Skipping a step again, A equals 11 times the sine of 51 degrees over the sine of 85 degrees. So A equals, let's type it in, 11 times the sine of 51 divided by the sine of 85. And I get 8.6. All right, now for our other case, so we have sine of 85 degrees over 11 equals the sine of 44 degrees over side B. Skipping a step, so B equals 11 times the sine of 44 degrees over the sine of 85 degrees. So typing that in, we have 11 times the sine of 44 divided by the sine of 85. And I get 7.7 for B. All right, so those work perfectly well. Those two cases, AAS, ASA, beautiful, we have one solution. Now, the hiccup comes in when we have SSA. In the SSA case, if you remember from geometry class, we actually could not prove two triangles congruent with SSA. Well, the same thing happens in Algebra 2. We actually don't have a definite answer. We could have 0 triangles, so no solution. We could have one triangle, just like we had above, or we possibly could have 2 triangles. So we need to test out the cases. For the 0 case, I'm going to know I have a situation when I get an error and I can't solve. Okay, for the 1, I'm only going to have one possible solution. The other one doesn't work. And for 2, I'm going to have 2 solutions. Okay. So basically, here's what happens. How do I know what I'm going to possibly have? First, I analyze. I look, do I have SSA? If so, I look at what I'm told. If I'm told an obtuse angle, I'm either going to have no triangle or one triangle. In my work, if I get an error, I have no triangle. If I don't get an error, I'm only going to have one triangle. Because remember, there could be only one obtuse angle, so that's only one possibility. Now, the big hiccup comes in if I'm told an acute angle. If I'm told an acute angle, I have a couple situations. I could have no triangle, I could have 2 possible triangles, or I could just have one triangle. Okay, so there are 4 situations that could happen, but really 3 answers. And let's take a look at what these situations look like. Example 2. All right, so let's draw this. We are given an obtuse angle, so let's draw a triangle with an obtuse angle. Here's angle A at 127 degrees. Here's B and here's C. Side A is 63 and side B is 42. So as you can see, SSA. This is an SSA case with an obtuse angle, which means either 0 or 1 solution. So let's go through our situation. So it looks like I'm going to have to solve for b first. So I have the sine of 127 degrees over 63 equals the sine of b over side b, which is 42. Cross multiplying, you have 63 times the sine of b equals 42 times the sine of 127 degrees. So we have the sine of b equals 42 times the sine of 127 degrees over 63. So then b equals the inverse sine, remember that's how we get rid of the sine, of 42 times the sine of 127 degrees over 63. And I'm just going to type that in and see what we get for angle B. So second sine of 42 times the sine of 127, oops, missed a number, divided by 63. And let's see if I get the answer here. B is 32.2 degrees. So that works, 2, so cute, fantastic. So then what I can solve for is C. So C is going to equal 180 degrees minus what I was given, 127 degrees, minus 32.2 degrees. So 180 minus 127 minus 32.2, and I get 20.8. So C equals 20.8 degrees. And that means now I can solve for side C. So I have the sine of 127 degrees over 63 equals the sine of C, which is 20.8 degrees, over side C, which is what I'm solving. Skipping a step, so C equals 63 times the sine of 20.8 degrees over the sine of 127 degrees. So C equals, let's check it out, 63 times the sine of 20.8 divided by the sine of 127. And I get 28.0. Which probably, yeah, I guess so. I don't know. 28 point. I typed that in right? Oh, that's side. Yeah. Okay, so that looks good. And we go. So we got a solution. So there was one answer. Done. All right, let's take a look at example 3. All right, so let's draw. We have an acute angle. So we have A, we have B, we have C. B was 52 degrees. Side A was 6.5, and then side B was 4.7. So again, SSA. This time with acute angle. So we could have 0, 1, or 2 answers here. So let's set something up. So we have the sine of 52 degrees over 4.7 equals the sine of A over, what was A? 6.5. I can't really read my writing there. All right, cross multiply. So I have 4.7 times the sine of A equals 6.5 times the sine of 52 degrees. So we have the sine of A equals the 6.5 times the sine of 52 degrees over 4.7, and then taking the inverse sine of both sides, we have this little expression. All right, let's calculator it. Inverse sine of 6.5 times the sine of 52 degrees divided by 4.7. And I get an error, which means no answer. So there's no triangle that works for this problem, or no solution. All right, let's try example 4. So again, let's draw the triangle. We have A, we have B, we have C. A was 62 degrees, side A was 32, and side B is 34. Again, SSA, acute, angle, 0, 1, or 2 solutions. Set up the first ratio. So we have the sine of 62 degrees over 32 equals the sine of B over 34. Cross multiplies, we have 32 times the sine of b equals 34 times the sine of 62 degrees. So we have the sine of b equals 34 times the sine of 62 degrees over 32. So b equals the inverse sine of 34 times the sine of 62 degrees over 32. All right, so then we get angle B equals. All right, so quit. All right, so second inverse sine of 34 times the sine of 62 degrees divided by 32. And I get 69.7, if everything is correct there. All right. So we have two acute angles. Let's see if I can get another angle. Okay, so that's one solution. So if that's one solution, then side C is going to, angle C is going to be 180 degrees minus 62 minus 69.7. So let's see what we get there. 180 minus 62 minus 69.7, and I get 48.3. That looks good, all valid. And then solving for side C, we have the sine of 62 degrees over 32 equals the sine of 48.3 over C. So we have C equals 32 times the sine of 48.3 over sine of 62 degrees. All right, so 32 times the sine of 48.3 divided by the sine of 62, and we get 27.1, and there is one answer. Now, here's the hiccup. So we check for the second solution. So B, it was 69.7, or B could be the supplement. So I subtract that from 180. And the reason that happens is because the law of sines, sine is positive in quadrant 1 and quadrant 2. So what we do is we find the reference angle in quadrant 2, and that's why we subtract it from 180. So we take 180 minus 69.7, and we get 110.3. So that's a possibility. So that's a solution. And if that's a solution, then I subtract 180 minus 62 minus 110.3, 62 coming from the original problem. And let's see what another possibility. Now, if I get a negative angle, then I know this was not a possible solution. And let's see, I got an angle of 7.7. That's perfectly fine. So this is a valid solution. All right, let's set up my ratio. So I have the sine of 62 degrees over 32 equals the sine of 7.7 degrees over C. Solving, we have C equals 32 times the sine of 7.7 degrees over the sine of 62 degrees. So 32 times the sine of 7.7 divided by the sine of 62. And we get 4.9. Yep, everything turned out to be hunky-dory. So there is another valid solution. So this one has two different answers. Okay. All right, so what I'm going to do for the purposes of this video is just not to do 3, 4, 5, or 6 on guided practices. I would recommend doing those by yourself, and you can come check your answers with me. But I'm going to move on to finding the area of a triangle. So if you recall, the old-fashioned area of a triangle is 1/2 base times the height. Now, this only worked when the base was perpendicular to the height, right? Well, what if you don't know what the base and height are if they're not perpendicular? Well, there happens to be a really quick fix to the formula. And that happens because you can always drop a perpendicular down, and that's your height of the triangle. And using trigonometry, you can rewrite the formula 1/2 base times height, and you get this formula. So basically, in a nutshell, it's 1/2 the product of the two sides times the sine of the included angle. So an included angle would be the angle between the two sides. And then you notice there's your A and your C, and there's your sine B for this case that I just pointed out there. So example 5, you are setting up a triangular flower garden in your backyard. If you lay off lengths of 15 feet and 11 feet for two sides of the garden with a 62-degree angle between those sides, what is the area? Right, so here's your garden. Here's 62 degrees, here's 15, and here's 11. So the area is 1/2 the product of the two sides times the sine of the included area angle. So plug that all in. So I would just type that in as 0.5 times 15 times 11 times the sine of 62 degrees. And we get 72.8 feet squared. And that's it. All right, so 7. Here's A, B, included angle C. So 1/2, 10 times 14 times the sine of 46 degrees, and we get 0.5 times 10 times 14 times the sine of 46 degrees. And we should get 50.4. All right, A equals 1/2 19 times 8 times the sine of 75 degrees. 0.5 times 19 times 8 times the sine of 75. So this area here equals 73.4. All right. Number 9. A equals 1/2 times 11 times 7 times the sine of 120 degrees. So 0.5 times 11 times 7 times the sine of 120 degrees. 33.3. A equals 1/2 20 times 24 times the sine of 87 degrees. 0.5 times 20 times 24 times the sine of 87. And we get, big one, 239.7. And there you go. I think that's the last one. Yeah. And again, I would try these guided practice problems. I don't have the answers off the top of my head. And feel free to come and see me if you need more practice on the law of sine.